Yeah, I think your voice is not audible for me. Am I audible to you?
Yes, ma'am.
Okay. Okay. I myself, Muga Ambigai, Assistant Professor of Parana Engineering College, belongs to AID's department. And today, my topic is that data structure for real-time systems. So before moving on to the data structure, how it is applicable for your system, first we need to know about what do you mean by real-time, right? Suppose when you, what are the various real-time systems we might have? Suppose when you take social media, right? So in social media, we are going to create a friendship with our parents. So how the data structure is going to make an impact on this kind of social media. And suppose when you take a flight control systems, right? So how here the data structure plays a major role. So each and everything we just need to know. And when you consider pacemakers, right? So when you consider a pacemakers, you might have known that the pacemakers plays a major role in affected the patient. So it is generally used to regulate your electrical shock or heartbeat within the system. Suppose assume that if the system fails for a few seconds, right? The system fails for a few seconds, actually it may cause an major loss to human life. Okay, and likewise when you take tsunami control systems or tsunami control devices. So how it works? Suppose if a particular tsunami is going to be appear after a few months, so it should be predicted in advance so that it can be intimated to the government so that major human lives can be retrieved. That is, a major loss can be eliminated. So suppose if assume that if the particular device fail at that particular moment, so automatically may cause a huge damage to the human life, right? So these kind of systems we call it as a real time. So normally how the real time system works. So before moving on to that, so this is a simple scenario about your real time system, and the now I'm going to say about an agenda. That is, these are the topics or these are the subtopics that we are going to deal today. That is introduction to real time system, why the data structure plays a major role in real-time systems, and how can we classify the real-time systems, and what is the data structure, what is the data structure requirement in real-time system, time and space complexity, and the comparison of common data structure for real-time system, memory allocation constraints in real-time system, programming constraints, and application and scale. So, as I said that, what are the real-time systems? So, when you take each and every real-time systems, here the sensor is going to play a major role. The sensor is going to get the input from the environment, and then with the help of those data, it is actually forwarded to the particular devices or particular applications. And through this, we can able to analyze the data, whether the data can be put to human beings. So suppose when you take flight crash system, that is flight control system, suppose assume that 20 minutes delay in correcting the pitch, it may cause an instability. So the sensors has to work perfectly so that the delay can be avoided. And suppose when you take a social media, how the data structure plays a major role is that suppose if we consider the n number of a persons, let me consider myself, and myself is usually represented as a node in the data structure. And likewise, the other peoples can also be represented as a node. Suppose if I want to maintain a relationship or a friendship with other person, normally that relationship is usually generally denoted by the edges. So each and every node is considered as a person, and the relationship is usually represented by the edges. So, like this, the data structure is going to play a and suppose, as I said previously, the real-time system must respond within a strict time limits, right? So, when you take a tsunami detection system, if it is not going to deliver the content in advance, so it is of no use, right? So that failure may be very crucial, or we can say that the failure will be very important to save the lives of humans. So the real-time system usually it should respond within a strict time limits. And how the impact of data structure plays a major role in real-time systems. So where are these are the few application areas. That is, when you consider the data structure, it should enable the fast, safe, and reliable system behavior in some domains such like this, healthcare, robotics, and then aerospace, right? Suppose when you take a printer system, right? So when you take a printer system, if n number of printouts have to be taken by n number of users. Suppose if each and every user is going to give the printout at the same time, what it actually does is that it is used to maintain a queue of the users, or it is used to maintain a queue of jobs, so that each and every job can be allotted or assigned within a queue. And then the first job which is come inside a queue will be allocated the printer first, followed by each and every one, right? So suppose when we are competing for a particular resource, so the competitive persons may put in a queue, one after the other. Normally, when you take a ticket reservation systems, or else while you're maintaining a queue in theaters, etc., like this, right? Those are coming first will be serviced first. So this we call it as a data structure. This is one kind of a data structure that will be in makes sense. Okay. So why the data structure in real-time system is very important? Because it should handle the data in a predictable execution. So as we know that so let me move on to this slide. So what do you mean by a data structure? So it is a way of organizing and storing the data for efficient access and then modification. Assume that we are providing the data to a computer, right? So where the data is actually stored. Usually we know that the data is actually stored in case of RAM, that is random access memory, and how it is internally stored and where it is actually connected. Okay, the way of representing the data and how it is linked. Assume that we are creating a file in a system, right? So normally we'll be storing the files either in a desktop or it may be in a folder or it may be in a subfolder, etc. like this. So before moving on to that, so when you want to retrieve those files, again we'll find out the entire path. Suppose let me assume that if I am storing the music folder in C drive. So what we'll do in C drive, we are storing the music file. Suppose if I want to retrieve the music file, so I need to find out the entire path, that is in C drive code, that is I can give the folder name music, and then within that music folder I can store a number of files. So this is the entire function. So here the data structure. So this is what I've said is that it is a way of organizing and storing the data for efficient access and then modification. So here in data structure we may be dealing with a number of variations, that is searching, sorting, etc. like this. We need to deal with whether the data is stored either linearly or it may be non-linearly. And here it is mainly important for task scheduling, sensor buffering, and then memory management. An example of a data structure is that arrays, queues, trees, and then graphs. Okay. So this is the entire scenario or entire structure of a data structure. The data structure is usually classified into primitive and then non-primitive data structures. So normally when you deal with the primitive data structures, so here we might have several data types. There is simple basic data type that we might have seen in several programming languages, right? So for example, if I am giving A equal to 10, so here A takes the value of 10, which belongs to an integer data type. If suppose I'm assuming a user equal to within a single quote, I'm giving a variable b. Okay, so that belongs to a capture data type, and then boolean. So normally here the boolean deals with the true or false statements, or if we can call it as, or either we can say it as either it may have a value 0 or 1. So 0 represents false and 1 represents true, right? So likewise, we'll be having a float variable and then a pointer variable. These are the basic variables or basic data types, basic data types that we are dealing with the data structure. And again, the data structure is classified, one among them is primitive and the remaining is the non. So when you take a non-primitive, it's again classified into linear and then non-linear. So when you take the term linear, so the linear itself, the term itself describes that all the elements that are stored within that particular thing will be arranged in a sequence, one above the other. Okay. So likewise, the reverse of this one is that non-linear. Again, we'll be having few examples of linear is that static linear and then dynamic allocation. So suppose when you take a static, here the example is given as array. As you know that array is used to store a homogeneous data type. Okay, so we can store, for example, if I want to store 5 elements of integer data type, I can go for array. Instead of storing each and every element separately, I can go for the array data structure. And then when you take a dynamic data structure, So the name says that dynamic, we can dynamically allocate the memory at a runtime, right? So the few examples of dynamic memory allocation is that linked list, stack, and then heap. And then when you come under a non-linear, we might have trees and then graphs. Suppose let me take the family heredity or family history of a particular person. Normally, all these data will be stored under a tree structure. So tree is normally going to have a hierarchical structure, and likewise the graph. It is also going to be represented, but not in a hierarchical structure. When you take a graph, you will be having a cyclic one. That is, it generally forms a cyclic formation. So in tree as well as the graph, in both the cases, we are going to have nodes as well as edges, etc. like this. So in previous case, I said that about the social media, right? So when we take a particular person, the person is usually represented as a node. So if I have a relationship with my mother, so that relationship is generally represented by the edges. So that tree data structure plays a major role in social media, that is Twitter, Facebook, etc. Likewise, when you take a graph, okay, so graph, suppose if I want to travel from India to, for example, to your country, so we might have several ways to reach your country. There may be various possible ways to reach your country. So among them, we need to choose which is cost efficient and what is the minimum distance to reach your country. Okay, so my target is that we need to have a minimal cost to reach your country as well as the shortest distance to reach your country. So here, several algorithms is also available in data structures. So that is implemented in order to provide. So now we can classify the real-time systems into three different types. That is, real-time systems are generally classified into hard real-time system, fast, firm real-time system, and then soft real-time system. So when you take a hard real-time system, so it must never miss the deadline. Okay. Suppose when you so here I have given the example that is pacemakers. So this pacemakers plays a major role in heart patients, right? It is used to regulate the heartbeat within a heart. Suppose it assume that if it waits for a few milliseconds, what happens? So it may cause the person to make a death, right? So that is very crucial. That is the pacemaker should work perfectly in proper manner. So that kind of thing that will be considered as an hard real-time system. So it must never miss the deadline. And moreover, we can also take that tsunami detection devices, right? So if it is not going to work properly, automatically it may be of a huge loss to a country. So that is hard real-time system. And suppose when you take a firm real-time system, so some occasional misses may be quite okay, but the result may be discordant. For example, live video analytics. Now I am making a contact, or now I am providing a live session with you, right? Few delay, a few delay is acceptable or negotiable, right? So suppose assume that if it is not going to be work properly for a long time, it is approved. So that comes under a firm real-time system. So suppose when you take a soft real-time system, so that may be a voice assistant and then streaming apps, etc. So this deadline will just degrade the quality, but not much of very hard when compared to the hard real-time system. Usually, when you take a hard real-time system, so the most critical job should have a priority over the other things, right? The hard reading system mainly deals with it just classifies for which task we need to give the high priority when compared to the other. Okay. So suppose if I am going to have higher official, okay, than me, as normally we know that the priority often it goes to that particular person instead of. So that we call it as hard reading. So we can classify these real-time system into hard reading system and soft firm real-time. Okay. Okay. So, in each and every day of your real-time systems, so normally we'll be having the data structure requirements, right? So, the data structure requirements in real-time system context. So, the first thing is that we need to find out the performance. So, how that particular scenario or how that particular situation works, and we should know the upper bounds. Suppose if I'm saying that if I want to reach your country um, within 5 years, is it possible? We need to check whether it is possible to reach within 5 years, or we should normally we should say the worst case scenario. Okay. So, for example, if I say that the time to reach your country is 5 years, I can reach your country either within a 5 hour, within a 5 hour is active. Okay. Suppose if it exceeds 5 hours, it is that is I'm not be predicting the upper bound properly. So that's the scenario. So we need to determine the performance properly and know the upper bounds. And then when you take in terms of CPU of the lesson, so the CPU may not be heavily loaded, the n number of items. And moreover, the memory should be properly handled. Suppose if n number of jobs are there, some jobs may not be live at that particular time. That jobs may be moved to the particular pool. Okay, so that we call it as a resource pool. So if the particular job is of idle nature, so that may be moved from your memory to a secondary memory storage instead of making it available in primary memory. So it just moved to the secondary memory storage. And when you consider the third one, the thread factors, which is often used in multitasking. So what do you mean by the term multitasking? Is nothing but we might be doing it in our day-to-day life, right? So suppose now I'm making interacting with you, or sometimes we'll be making browsing in Google, and likewise similarly, we can hear some audio. We can open the other tab and we can hear some audio. So we are doing more than one task at a time. So this we call it as multitasking. So while performing a multitasking, so each and every job is involved with n number of the threads. Okay, n number of the threads. So in operating system, actually we know that the threads may be classified into user level threads and then kernel level threads, etc. So here the thread safe access should also be ensured while we are doing it. And then the next thing is that it must support the non-blocking or lock-free operation wherever possible. So non-blocking or lock-free operation, this generally deals with the high priority process. This generally deal with the high priority process and then low priority process. As I said previously, suppose if a high priority process requires a resource, assume that that resource is currently held by some other low priority process. That should not be done. Okay, because the high priority process, the priority is generally high priority in terms of that it should need immediate attention, right? So if the resource required with particular high priority process is not available at that moment, automatically the work will be delayed. Okay? So it should support a non-blocking or lock-free operation wherever. And here comes with the time and space complexity increasing. So what do you mean by a time and space complexity? So time is nothing, but in data structures, we might have n number of algorithms, as I said previously, sorting algorithm, searching algorithm. Each and every algorithm, we can evaluate the performance of the algorithm based upon the time it takes to execute, as well as the amount of space it requires to be stored in memory. Okay. So that is generally determined by few conditions, that is order of that is big O of n factorial, big O of c power n, big O of n power c, etc. So when you consider the basic things is that order of one. Okay. So when you take a linear search, so normally it takes an order of one number. Okay, order of one. And suppose when you go for an A with tree, so this A with tree will be considered as a balanced binary search tree. So suppose when you take this is order of log of n. For few application, it is feasible to use this order of n. Okay, and for other application, it is feasible to choose order of log of n. So based upon our availability and based upon our requirement, we can go for the space requirement as well as the list. Okay, so in real-time system, which one is best, good and fair, bad and reverse? So this I listed a few. So it is better to have an order of one. Okay, so that is considered be and best for real-time system. And suppose when you go for good, fair, etc. like this. So when you take good, it is nothing but order of log of n, and like this order of n, it is bad and then worst thing. So according to our application needs, we can go for using certain kinds of an algorithm. In suppose when you consider searching algorithm, there may be a classification of linear search as well as the binary search. Okay, so when you take a binary search and linear search, there may be a few differences in the working performance. So based upon the working performance, we are having this order of one, order of log n, etc. So according to our availability and according to the applications that we have said, we can choose the algorithm. So and normally how it makes an impact is that how the time and space complexity differs is that it is generally based upon the input size which is taken for the algorithm. Okay, so suppose if there are 100 items that need to be searched, okay, automatically we know that it takes a lot of time to complete that. Suppose if you're having only 5 items, if I want to search a particular item within the 5 items, so normally the searching process is limited. Automatically, we can reduce the time. So that we call it the time and the space content. Space in a sense, the amount of space which is occupied within a memory in order to store those things. So all these need to be considered in case of a real-time system. Okay, and here this is a few examples for common data structure that is used in a so when you take an array, it is going to have a time complexity of order of 1 and linked list order of n, queue and stack, which is heap order of log n, hash table order of 1, and in worst case, it is order of n. Okay, so among this time complexity, we can say that whether it is suitable in real-time systems. Sometimes this array would be more efficient so that we can prefer the array form. Okay, so whereas when you take a linked list structure, so it is not suitable. So because when you want to provide or when you want to one more new node into the data structure, automatically you are in need of several pointers, right? So suppose when you take a single linked list, automatically we are in need of a single forward pointer alone. So when you go for doubly linked list, we'll be having a forward pointer and then backward pointer. So in order to insert a particular node, we are in need of more space when compared to the array. So automatically this linked list is of less less performance when compared to my array. Okay. In some systems, we may make use of a queue stack or maybe heap data. I think you might have known about the stack and then queue. Okay. So when you take a stack data structure, so if you make a list of books to be one file for the other, okay. So the first one to be removed is the last one which is inserted. So normally, that stack is going to follow a last in first out format, and then queue is going to follow the principle of first in first out format. And when you go for the heap, okay, just I'm giving a short introduction about each and everything. Okay, so when you go for a heap data structure, so here we can classify the heap into min heap and then heap. So it is going to have a tree-like structure. Okay, so if it is going to be a min heap, the root element should be the minimum element in compared to and, when you go for the next one, normally we'll maintain the maximum element at the root when compared to the other elements. And hash tables. So this hash table here, I can say give a few examples for hash table where it is implemented. For example, when you make a search in Google, right? When you make a particular search in Google, so depending on each and every person will give a specific keyword, right? So suppose if I want to know about array, I can give some details about array. Some of the persons may give that is definition of array. Okay, so the main keyword used over here is that array. So the hash table is used to find out the keyword while we are searching. So based upon the keyword, it is used to find out or search the entire content within a web page, and then it will give the details. Okay, so like this data structure is applicable. So we are in real-time applications such as how to find out a particular content within a web page. So this should be used with caution. So that's why it is when it doesn't condition because here hash table generally deals with key value pair. Okay, so it will take a few times to just like an indexing. It will also take a few time to search the content within the page. And then it comes the memory allocation concerning real-time. Suppose if I'm choosing a particular type of a data structure, for example, if I'm choosing a tree data structure, so I should consider what is the time complexity of tree and then space complexity of a tree, whether I'm going to use any other particular, if the insertion and the deletion of node within a particular tree is easy or not. So all these factors should be considered while I am taking or while I'm adapting to that type for data structure within our real-time system. So that's why we are dealing with each and everything. Okay. So that is the next one is that avoid dynamic memory allocation. That is the MLOC and then 3 due to unpredictability. Because MLOC generally deals with a memory allocation, right? And the next thing is that suppose free generally deals with that. Suppose if the job doesn't play any role, right? If it is of no use at the particular moment, automatically the memory allocated to the particular job will be automatically free. So when you take into one consideration, so normally we should avoid the dynamic memory allocation because we doesn't know whenever we are in need of the space again. Okay, so since due to an unpredictability, So we should be aware of using only static memory. So the preferable one is static. So when you go for the static allocation, an example for static allocation is that you can consider the array of elements, right? Suppose if I want to store a list of 5 elements, automatically the array size, I can give the array size instead of giving the array size equivalent to 10. I can give the array size equivalent to. So that is of within a. So okay, because instead of specifying 5 allotted space for each and every element, so if I give 10, automatically the 5 space allotted for that is of no use. So that's why automatically we can prefer the static application. And then the next thing is the fixed size flow, generally inside the memory flows. Right. So normally, if a memory space allocated to the particular job is of no use, automatically it will be freed by the resources. The resources allotted to that particular job will be freed, and it should be moved to the pool that we call it as a memory. And then the next thing is that it should prevent the fragmentation and unpairs. So fragmentation generally reads, suppose assume that your job size may be of 20 KB, right? If the job size may be of 20 KB, the space should be automatically allocated to the job. Suppose assume that the space allocated to the job is of 50 KB. Okay, my process or job size is 20 KB, but actual space allocated to the process is of 50 KB. Automatically, we know that 30 KB is of no use, right? So 20 KB will be allotted, right? So the remaining 30 KB, that we call it as an fragmentation. Okay, so we must be very cautious while allotting that space, because sometimes there may be enough space. If a new job comes, we may not able to accommodate that particular space to that new job. So here again, the fragmentation, generally we classify the fragmentation into internal fragmentation and then external fragmentation. This is a concept behind an operating system that that I am not going to touch more. Okay, so in order to avoid the fragmentation, normally we'll use one more technique that we call it as coalescing technique. Okay, so that is the coalescing technique is that we automatically move all those free segments or free space towards the one end, so that a large space will be created. So if a new job will come, automatically that space will be allotted to the new job. And then the next thing is that what are the programming constraints we need to take in taken into an account of while taking into an account of airline. That is no garbage collection or heap collection during the runtime. So during the runtime, garbage collections or the heap collection should not be done. And then limit the recursion, avoid deep call stacks. So what we call this that limit the recursion. You know that recursion is nothing but of course when you take a function which call by itself again and again. So that we call it as recursion. Or this recursion should also be avoided. Okay, as well as the deep system call. So normally when you take a function call, we'll be implementing a stack data structure. So whenever we call a function, automatically we know that our cursor will move on to where the definition part of the function call resides, right? So when we make a recursion, since we are calling again and again, so instead of executing that particular call, particular definition part of the function call, again when it calls again and again, an n number of variables will be stored or stacked or piled up in the stack. Okay, so this will create a complication, or this will create a lot of time to be wasted. So that's why they are saying limit the recursion and avoid the deep calls. Okay, and use the pre-allocated buffers, pre-computed tables. Okay, so instead of going for getting an excess buffer, so a pre-allocated buffer should be preferred while we are making the program, right? And then the task must be bounded in execution time and memory usage. Suppose if I'm saying that if I'm going to execute the program within 5 minutes, it should be possible to execute the program within 5 minutes, and we should produce the output, right? Same way. So whatever the task which is assigned to a particular process or it may be a job, the task must be bounded in time. Okay, it may not exceed the particular time, as well as it may not exceed the memory which is assigned to that particular process. And then what are the applications of real-time schedules? So here we might have used some priority queues. So priority queues is nothing but what I said previously, that is heap and mass. So normally for the task selection process, will be using a heap-based structures. And here this may be just binary heap for scheduling used by operating system, that is TRTLS. We generally use the binary heap. and then circular buffers sensor data. So as I said that in real-time systems, we are making use of a sensors in order to get the input details. Okay, in order to get the input details. So while we are getting the input details, where the data can be stored and which type of a data structure. Supportable data structure here is a circular buffer. So normally when you take a singly linked list or a doubly linked list, right? Suppose we cannot able to insert one more item. Suppose if the size of a linked list is of, for example, 5, instead of going for the singly linked list or doubly linked list, when we go for a circular buffer, whenever that portions of, for example, if the first space tends to be empty, automatically we can able to insert one more item into the available space. That is in case of a circular buffer. But if it is not, I think you might have imagined the circular buffer. So assume that the circular buffer, it will be of connected one. Okay, it will be of connected one. That is the start node and the end node will make a connections so that it will form a ring-like structure. Okay, assume that the first space is available. Assume that first space is right. If I want to insert the particular node, automatically it shows that the first space is available. You can insert your node, but this is not possible in case of a single basis, or it may be in terms of an abbreviation. Okay, so the preferable buffer, likewise, the preferable buffer here, it is it is acceptable as club buffer in sensor data. So fixed size ring buffer for fast input output. Why we are using a fixed size ring buffer is that in order to make fast input output functions. Okay, which override the oldest data and code. Suppose assume that the circular buffer is full. Okay, if I want to store the new data, automatically the oldest data will be automatically erased and the new data will be just actually stored. Okay, so this is what happens in case of audio streaming and ECG signal processing, IoT, etc. When you perform an ECG signal processing, that is the current data will be available. Okay, automatically the old data will be erased. So that's why they are maintaining a circular buffer in sensor data. And when you come for ABL tree, so when you come for ABL tree in a file window, so ABL tree one, ABL tree is nothing but before moving on to an ABL tree, we'll be having various variations of trees, that is binary tree, etc. So the one attracting feature of ABL tree is that it is a balanced binary search tree. Okay, so when you take a left subtree, here we will be crossing the terms that left subtree and then right subtree. So both tends to be balanced. Okay, so normally we'll be having a balance factor. How can we check the tree whether it is balanced or not? We'll be having a balance factor that is plus 1, 0, then minus 1. If it exceeds the limit apart from minus plus 1, 0, minus 1, we can say it is unbalanced. In such a cases, we'll be performing some rotations. The four kind of rotation is there. So rotations, so that is the single rotation, double rotations, etc. Okay. So by performing all such kind of rotations, automatically the tree will be balanced. Okay. So for that thing, we need to find out the balance factor for each and every node in a avian tree. Okay. So all these need to be considered. So generally, the avian tree since it tends to be somewhat complex while doing the operations, but it is best suitable because why we are saying that it is a balanced binary search. So in some situations or some scenarios, this is most preferable compared to other kind of trees. So it is used in real-time systems in order to manage the file names, directory structures, and then metadata. I think you might have known file name, right? So when you create a document, right, normally we give a file name. It may be a text file or it may be a docs file, etc. Like this. And then the next thing is the metadata. So this metadata is used to store the information about the files that we are storing. Suppose if I'm storing a file, it will give an information about who is the creator of the file and when the file has been modified, when the file has been created, and when the file has been last modified, and where it has been stored, under which directory, and which folder it is stored. All these details regarding a particular thing that we call it as a metadata. And then the next thing is that linked list in kernel structures. So linked list in kernel is affected that kernel is nothing but it is the main core of your operating, right? So in kernel structures, here we are going to make use of a linked list, right? So while we are making use of a linked list, we must be very cautious in handling interrupt handler chains. So I think you might have known about the Mumbai interrupt. So possible. I'll give you a simple example for interrupt. Suppose if now I'm taking a right, so now I'm taking example. Suppose assume that if a power turns off. Suppose assume that if a power turns off, okay, so that we call it as an interrupt. Okay, and again the power can come. Okay, so I should recall or I should fetch from where I left off in order to continue my session. Am I right or not? Right. So or else I can say if I'm giving an talk to you, right? If some person comes and calls me, so that time I should respond to that person. Okay. So that person who disturbs me, we call it as an interrupt. So this is a simple example. I think I'll be more clear to you. Okay. So that interrupt handler change should be properly managed because when you take an operating systems, each and every case will be having several jobs, and each and every job is associated with a priority, right? Always, we never say that always each and every job should have an equal chance of doing their work. Okay. Suppose if a low priority process runs and if a high priority process comes in, automatically the low priority process has to leave from that situation and give that resource which is needed by the high priority process. In such a case, it may lead to some uncomfortable situation that we call it as a starvation. The low priority process will never get the resource for a long, quite long period. Okay, so that we call it as a starvation process. So that's why we generally say that inter-handler change should be properly or it should be cautiously done. Okay, and then device driver list. So device driver, each and every device is going to have a driver, a specific driver. Suppose if I'm inserting my cable, okay, if I'm inserting my headset, automatically pop-up menu will appear that a new device have been inserted, etc. So for each and every device, we are going to have a specific device driver. Okay. So what they're trying to say is that we just be very cautious about while we are handling interrupt handler change as well as the device driver list. Okay. So this is a simple example I've given that is RTOS, which generally deals with interrupts service routine vector table while using a singly linked list. And this we call it as a skip list. So skip list for sorted queues. So skip list is nothing but normally suppose when I consider 10 nodes, okay, when I consider the 10 nodes, instead of traversing from the beginning of seeing the first node to the 10 nodes, I can skip some of the nodes. For example, if I want to, I don't know the exact route from India to Indonesia, uh, I'll be telling, I'll be telling the example, but it might not be exactly correct. Okay. Uh, from India to Indonesia, suppose if I have to bypass between two countries, if I assume that if I have to bypass between two countries, the cost of reaching from India to Indonesia, it may be around 50,000. Okay, 50,000. And suppose, let me assume that if I have to bypass three more countries in between India and Indonesia, the cost may be 20,000. So I'll prefer the second one because the cost is very less when compared to the first one, right? So I can skip some and suppose if I want to travel, likewise, if I want to travel from here to 100 kilometers distance. So when you consider passenger train as well as the express train, right? A passenger train may have a halt at each and every stations. Okay. So whereas an express train may not have an halt at each and every station, it may skip some of the stations so that we can travel or reach the destination in a proper time. So that likewise here we are going to have a skip list for sorted queues. Okay, we might have a number of nodes. We'll skip some of the nodes so that we can easily reach the destination. Okay, so this is a simple concept of the data structure. So which is actually simpler than trees, which is also going to have a good concept. Okay. So here the performance is mainly used in real-time financial feeds and then RT cache replacement algorithm. So this cache replacement algorithm, these and all the concept comes under an operating systems. So under cache replacement system, we'll be having various variations. That is first in, first out, and then LRU, like least recently used. We are having n number of replacement algorithm. And according to our applications, we need to find it out which one is very feasible uh, to the applications that we are making use of. Okay, so based upon that, we need to take it out cache replacement algorithm. So that is a separate topic behind an operating. It's also very important within that. Okay. And then what I've said previously is that log free queues for multi-threading. So I think you might have known about a multi-threads, right? More than one thread. Suppose in order to perform a particular job, there might be n number of threads which is used to do that particular job. So each and every job is going to have a part of task. That is, the entire task will be divided into fewer tasks, and each small portion of a task is assigned to a threads in order to complete its work. Okay. After completing each and every thread, after completing its work, the whole work will be accumulated as a one, and we'll find the output for the final work. Okay. So while we are performing a multi-threading process, it should eliminate the locks and prevent the deadlocks. Okay. So a lock is nothing but suppose if I'm using, assume that if I'm using this computer, right? I'm saying that the other person don't use my computer until I leave the computer. Okay. Because since I'm making a session with the students, don't interrupt me, or you can use this computer after after I complete my sessions. So this we call it as a lock. Okay, so I am locking this resource. The resource is nothing but your laptop. Okay, I'm locking this resource for a particular while. Unless and until I can leave the lock, release the lock, it cannot be used by some other persons. Right? So automatically, while we are dealing with the multi-threading, we should eliminate the lock. Okay, and prevent the deadlock. And suppose when you consider the deadlock situations, you might have just imagine about a four-way road. You might have imagined a four-way road. Assume that in each and every lane, there may be some kind of vehicles which will be stuck in together, so that each in every lane we cannot able to proceed further. At least one of the lanes should be free, so that the remaining vehicles will be moved, right? So that's kind of situation we call it as a deadlock. So the lock-free queue is generally used in RT trading platforms and then robotics for task pipelines. So here we are going to use some kind of work that is generally with the operating system, that is compare and swap operations. So that is applicable in case of using this applications. And then the next thing is that graphs in navigation systems. So when you consider navigation, so what I've said previously, if I want to travel from India to Indonesia, so that we call it as navigations. So I just imagine that I'm unaware of how to travel from here to there. I'm just making use of a Google map, etc. Right? So here that map is generally considered or it is implemented with the help of a graph. So normally we can classify the graphs into two different ways. In case of a data structure, that is the depth first traversal and then the depth first traversals. Okay. So this is applicable while we are making use of model or rules or arrays for pathfinding. So here the specific algorithm that here we are using is the Digitas algorithm, which is normally used to find out the shortest path. What I said previously, if I want to reach from India to Indonesia, there will be several possible ways. So from that several possible ways, I need to find out which one is feasible to me. So which one is feasible to me? The factor includes the cost as well as the time it takes to reach from here to there. Okay. So that is generally the shortest path will be find out with the help of the algorithm that we call it as a Digitas algorithm. So in order to find out that shortest path, we are making use of an adjacency list. Okay. This is a topic within in a data structure, but I am not including much more concept based upon that. Just I am giving an outline for this, right? Since we are dealing with how it is applicable in real-time systems. So this is the graph navigation systems is generally used in drones for path planning and rating global positioning system that you might have known, and drones for a path planning. Okay, so from where to where it has to travel, etc. And how to calculate the optimal flight path while avoiding no fly zone. Okay, and then GPS navigation systems. Suppose when you consider, so we need to find out the dynamic route update based upon the traffic. And when you consider an autonomous robots also, it uses the graphs for indoor or barrows. Okay, so why it works in real-time systems? Okay, so why it works in real-time systems? Because each and every algorithm have predictable behavior. The adjacency list generally ensures the low memory footprint, so it can be optimized for real-time systems. Okay, and then the next thing is that tries for prefix matching. So just for your understanding purpose, I have given you this image to you. So this we call it as a try data structure. Suppose when I consider the word and, okay, So we generally start with the root node. In case of a trie data structure, we doesn't have any node representation within a root node. Apart from the root node, we'll be storing each and every letters. Okay, suppose when I consider and, we can give from the root node. So we follow that particular edge, we can give A. Okay, A, N, and then D. So you can get the word and. Okay, see, listen, A, N, and then D. Suppose if I want to store one more word and, so instead of drawing A, N again and again, I can take the same root A, N, D. So this is okay. Like this, when you take a dad, D, A, D. Again, suppose when I want to deal with another word, do. So instead of making it another part, we can go for D, O, do. So this we call it as a trie data set. This is normally used to minimize the memory space also. And suppose when this is stored in such a way, we can easily retrieve the data from over. Suppose if I want to find out that, I can go from the root node. When my searching starts from the root node, D, A, D. Okay, that way I can get. And for example, when you take a do, D, O, that way. So normally we know that if I narrate the story, it will not be more convenient for you when compared to while I'm providing visual representation to you, right? The visual speaks more when compared to an oral representation, right? So that's we call it as a tries for prefix matching. So this generally works up faster. So that's why we call it as a fast lookup by character level. Okay, so this is used in real-time DNS, that is domain name resolution system. So domain name system resolution, and then it is also used in autocomplete systems on embedded Linux. And then real-time streaming purpose. So just here also I have given image for you, right? So an image may be having foreground as well as background. Assume that if I'm seeing a video, okay, sometimes you might have been your eyes may be rotating, your two eyes may be rotating in such a way that some foreground image may be more clear to you. So at the same time, we'll be having the background image tends to be very blurred. Okay, but again within a few seconds, this will be blurred and this will be more clear to you. So that fluctuations will be occurring within a few milliseconds, and that we call it as a flickering. Okay, so the flickering often occurs within a few milliseconds, so that the image will be very clear to us according to our eyes. Okay. So this we call it as a double buffering method. So one buffer is used for foreground and another buffer is used for a background one. Okay. So here the circular queue is maintained. So this is where the application area of the real-time streaming buffer is, the live video audio capture as well as AI speech detection methods. Okay, so in such a case, this kind of data structure, that double buffering method, is used. And then scheduling queues in RTOS. Okay, so in RTOS, so as we know that normally here will be maintaining n number of functions. So here we can classify three different queues, that is job queue, ready queue, and then IUV queue. So whenever a new job arrives, it is actually put under a job queue. Okay. So if it is ready to receive the CPU, if it is ready to receive the CPU, it is put it into a ready queue. So whenever the CPU is assigned to this job, automatically it starts executing. Okay. So here we are given the new term, that short-term scheduler, which is nothing but CPU is called as a short-term scheduler, and then this we call it as a long-term scheduler. Okay. Suppose while it is processing, while it is doing its work, whenever an input-output request has been raised, it can be automatically put under an IO waiting. So after the input-output has been done, again come back to a ready queue. And finally, again when it gets the CPU, it will finish its completions and then finally it comes up. Okay. So we are maintaining three different types of queues. That is ready queue for active threads, which is nothing but an array of queues. And each priority level has its own first in, first out. So as I said, that suppose if n number of jobs are have been arrived here, okay, and all the jobs are ready to receive the CPU. So we need to decide that to which particular job we need to assign the CPU at present. So that is generally based upon the priority. As I said, that each and every job is associated with a priority. Based upon the priority, the highest priority job will get the CPU first. Okay. After the completion of that highest priority job, the remaining jobs will continue. So that is using some kind of fun OS, that is VRTOS, and then use, and then inter-task communications. Okay, shared memory is circulating. Signals and semaphores used in simple queue-based waitlist, which should avoid the priority inversions. So what we are dealing with that here the main thing is that must avoid the priority inversions, right? So priority inversion is that suppose I've said the previous scenario that suppose if there are two processes, assume that one is going to have high priority than the other. If the high priority process is running, right? So suppose if it is in no need of the resource that is actually held by the low priority process, automatically what it should be done, the low priority process has to release that particular resource to the high priority process. Assume that again the high priority process needs some other resources which is held by some other low priority resources. In such a case, always the high priority process will get the chance. The low priority process tends to be stopped for a long time. So in order to overcome this situation, we just reverse the priority. So that priority we call it as an inverse. So that the low priority process will get the high priority at a moment when compared to the high priority process. So automatically, just what I can try to say is that we just change the role of each and every persons, right? Assume that if I am going to be a president of the country, and if the president of the country tends to be a normal person just like me for one day, just like that. So that we call it as a priority inversion. But in case of maintaining an intertask communication, that priority inversion should be avoided because according to the real-time scenario, it is more appreciable, but it is not always acceptable, right? So that's why they are called it as we just need to avoid the inversion. And the real-time databases. So the real-time databases, we just maintain a tree just like this, so that we call it as an indexed binary tree for transaction lookup. So for example, suppose when I want to take a mini statement or when I want to find out what are the last three transactions that I've done in my account. Okay, so what we'll actually do, we can go for an ATM, get a mini statement, or we can log into an ATM. Sorry, okay, we can go to an ATM and get a mini statement, or we can log into a net banking and we can get the past three transactions which is done by me. Okay? So all these transactions will be generally stored in case of this structure. Okay. So that statements may include the various locations where we are making withdrawal or where we make an inquiry. Okay. And whether we have crossed that particular limit. etc. So in order to view the last few transactions, we can go for taking a mini statement. So that mini statements generally it is going to have internally it is going to follow a data structure just like this. So that is BT data structures. So in case of a BT data structure, suppose when you take this, so all the left side value should be it is generally less than the root node. On the right side value should be greater than the root node. Okay. And then suppose when you assume that a flight control system for each and everything, how we are going to use. So for sensors, we'll be using a circular buffer, and for actuator, we'll be using a priority queue, and then terrain map storage, we'll be using an AVA tree. Okay, and then all data is timestamp as well as the bounded. So suppose while I'm fetching a particular data, we just need to know from where it is collected. So normally here it generally deals with the GPS. Okay, so that particular location, date and time. Okay. Suppose when I am taking a view of a mountain and how and the view of a mountain, whether it is leading towards north or whether it is leading towards south, etc. like this. Okay. So all these details will be considered while we are making use of a flight control systems. So for each and every sensor will be going to have or adaptable or we are going to have a separate data structures. So as I said that for sensors we are going to have a circular buffer. For actuators, priority queue and terrain map storage, we are going to make use of AVA tree, etc. And the next comes the medical devices. This so you might have seen in real-time system, right? So while we are taking an ECG monitors, so automatically the live data, that is current data, will be automatically stored in a ring buffer. So that will be having a 10-second sliding windows. The sliding window concept generally comes under the networks, right? So we'll be having predefined fixed windows. So as the data have been passed away, the windows will move one step forward. Okay, so this is an entire topic within the networks. So and then the patient data in AVL tree for quick patient ID match. So because since AVL tree is going to have balanced binary system, automatically when we want to make a search, we can go for suppose if the root node is 10. If I want to search an element, for example 5, definitely I can trace it out. The element will be available in the left side instead of the right side. Okay, automatically we can go for the left side so that I can find out the right match. Okay, so instead of if I'm saying in terms of numeral value. Here I have taken the patient details. So suppose if I give the patient value, for example, 101, suppose if the root node is 100, definitely I can search the patient ID on the right side instead of moving on to a left side. The same thing, okay? So this is generally used for a screen navigation in terms of medical. And likewise, this is in terms of a medical devices. And when you consider an autonomous input, so here for room mapping, we'll be making graph, and as well as IR sensor input, we are going to make use of circular queue, and then for motor signal processing, we are going to make use of a log tree queues. And what we've said, the key design principles. So suppose if I'm saying that this particular type of data structure is applicable for this current application scenario, what are the design principles that we need to take into account? Okay. So as I said previously, so always stick on to the static memory location whenever possible. So instead of going for dynamic memory allocation, because sometimes the dynamic memory allocations may lead to a uh, memory usage, that is lead to a poor memory usage sometimes. Okay, so as much as possible use the static memory allocation whenever possible. Okay? And then favor the deterministic structure over the average case fast ones. So deterministic structure is that we need to have predefined structures. So we need to have a predefined structures instead of having a suppose if I say that I can do this work within 1 hour. So that should be a deterministic value. So I should complete my work within that 1 hour. If it exceeds, it comes under non-deterministic. Okay, always stick upon to the data structure uh, based upon the running time, as that is nothing but a time complexity. So which generally means with a deterministic structure, and avoid the worst case timing. Okay, and the minor final conclusion is that the data structure is not just a logic. Their system enables a real-time environment, right? So the proper structuring usually generally involves safety, performance, and then scalability. So in case of a safety, we can go for the example of medical industry, and then performance, that is autonomous system, scalability, that is generally being with IoT devices and then AI devices. And so, what I try to conclude is that so depending upon the applications that we are using, right? So depending upon the applications that we are using, we just need to stick upon to the data structure. We need to select which kind of data structure is well suitable. For example, uh, as I said that if I want to travel from this place to your country, what kind of algorithm is suitable for that in order to find out the shortest distance? So instead of going for arrays or queues, we can stick upon to a Digitas algorithm. So that algorithm works well for navigation, right? It will find the shortest distance in order to reach your destination. So according to the applications we need to stick on to the data structures. See here I've listed only a few types because I may not be having enough time to teach you about how the linked list entirely, how it works, how the insertion and deletion can be done, and how the graph structure. Because in graph we can have two different variations. Okay, that is depth first traversal, and then one more thing is there, right? But I may not be having enough time for this, so that's why I'll be restricting to this because so these are all the data structures that comes under into scenario. So depending on our applications and our usage, we may be stick upon to any kind of a data structure one among this, right? Suppose if we want to service the person who comes first, we can stick upon to a queue. Stack is that suppose if I arrange a pile of records one above the other, right? So suppose if I want to remove the first one, what will do? Will automatically keep the topmost one on the right? So in such a case, if you want to have a real-time situation just like this, we can go for a stack. And when you take a linked list, right? Linked list, here there are various classifications, single linked list, doubly linked list, and then circular linked list. Okay. Singly linked list is the suppose if I want to assume that there may be existing three nodes. If I want to insert one more node at the last, automatically we can insert that node to the last with the help of a pointers. Whereas in case of doubly linked list, will be having a previous node that we call it as the predecessor node as well as the successor node. Okay, if I want to insert a node, we need to have two different pointers, which one points to the previous node, the other one points to the upcoming second node. Okay, so likewise, according to the situations that we have, we can directly pick up the data structure. These are few data structure applications area and real-time system that I have given you, right? So this is a separate concept. How can we calculate the order of one? And this might have the basics in data structure. I think this. I hope that you might be aware of those concepts. Okay. I hope so. I have listed out what I've known to me. Okay. So this is the thing, and I just go for any queries from your side. Can you type it in the chat box?
Yes. We have some question, ma'am, already read in the Zoom chat.
Yeah, sure. Ji?
Hello, ma'am.
Yeah, I'm hearing. See, you just asked a question that in which cases the static allocation uh, is suitable, and in which scenario the dynamic memory allocation is suitable, right? So when you go for sometimes when you go for static allocation, right? So static allocation is that we just know in advance, right? Suppose if I want to store 5 elements, so automatically we can get the space for only those 5 elements. Okay. So in array usually generally follows an static data type. So suppose if I want to store initially, I just think that I want to store 5 elements, I can give the space for that. Suppose in case if I want in future, if I want to add some more elements to the array, it is not possible, right? So normally why they are saying it's a dynamic memory application. Sometimes we need to avoid the dynamic memory application is that suppose if we are in need of the particular thing at a moment, it is possible with the help of a dynamic memory allocation, but in case of a dynamic memory allocation, some of the resources may be of no use. Okay. Suppose if I am saying that I am in need of several resources, for example, file as well as printer, I am locking in advance. I am locking in advance a file, printer, and a system, etc. like this. But at a particular moment, the printer may not be needed by me, right? But I am pre-booking in advance. So in such a case, it should be avoided. Okay. And what the next question?
I guess no one else asking again, ma'am.
To
Yeah.
what extent should we prioritize time complexity over space complexity, efficiency in selecting the data structures for real-time systems? Okay, in real-time systems, such as, for example, embedded systems, okay, automatic control systems or medical devices, that is, which generally demand a predictable and fast executions. Okay, in such a cases, the delayed or missed deadlines can lead to a serious consequences. So, what I said previously is that, for example, when you take a pacemaker, the pacemaker should work properly in so that it can trigger or activate the pulses of a heart patients, right? Suppose if it fails for a particular few milliseconds, for example, 20 milliseconds, automatically it may lead to a huge human loss. To what extent should we prioritize time complexity over space efficiency in collecting the data structure for real-time environment? Okay, so while you're considering each and every algorithm, not only that algorithm, generally, each and every algorithm, we are going to have a separate time complexity as well as the space complexity. We should have a streamline that so that The time should also be, that is, the running time of an algorithm should also be very less, as well as the space occupied by that particular algorithm should also be very less, because the memory should be efficiently used, right? And normally we know that the memory is utilized by all the process or all the jobs that are being created dynamically. So, in order to utilize the memory, we should stick upon to the algorithm that is going to have at least time complexity, as well as the space complexity. Generally, we'll be sticking on to an order of one. Okay, so order of one. In some scenarios, we'll be sticking on to a complex data structure that is nothing but an ABL tree. But according to the situation, I'm saying again and again, according to the applications that we are needed, we'll be sticking on to a particular type of data structure. So that may not be feasible in all the cases, but depending upon our situation, we need to stick upon to it. We need to make an survey that, or we need to make an analysis that which algorithm is best suitable for our applications. Likewise, we need to make it in an algorithm.
Yeah, okay. Thank you for answering, ma'am. I guess no one else asking again.
Ah,
Hello. Yeah. Okay, before I close this event, for all participants, please open your camera. I will take a picture on the count of three. Okay, 1, 2, 3. Okay, another one. 1, 2, 3. Thank you. Thank you for your keen cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Dr. Mohambigai for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice